I am Jarek Kurnitski, professor at Tallinn and Aalto University and energy stream leader in Finest Winds project. So we'll try to speak very briefly about energy research in smart cities, and this presentation is based on two examples basically of research projects. First, I will start with the fact that buildings account a lot of final energy use. This is up to 50% of the total final energy use, and that mainly takes place in large cities. So there are many challenges regarding to energy, but not all of them in cities. We know very well that heating of buildings and transport are major CO2 sources in cities. But when we speak about energy improvement measures, what are typically funded as renovation grants in Estonia by KredEx, in Finland by ARA, then this is not so much in the scope of the cities because this is a state level, so a national activity. When energy production, what is mainly district heat production, this very much belongs to the city's responsibility, and in Helsinki even is owned by cities. So this is highly relevant how to decarbonize district heat production, and also to coordinate efficiency measures in buildings together with measures in energy production so that maximum CO2 reductions would be possible. This is also very challenging. Just will show one example on that topic. Then what comes to the city planning and architectural aspects in building renovation, these are indeed very much in the scope of the cities. And cities may also set more strict energy and other sustainability requirements than these in the national minimum requirements, and this is, for example, widely used in Helsinki. Large cities are also large building owners, so building level energy performance also will matter. This is one example about a large study where full energy production mix in Helsinki was modeled, so including all district heating and cooling plants based on co-generations or heat pumps or other technologies what have been used. And also national grid electricity production was coupled to this model, and the model included a full building stock model of a city. And with such model it's possible to test what is effect of some energy efficiency measure in the building on the total CO2 emissions. For instance, if we install heat pumps to apartment buildings or to other buildings, we can see what happens in the CO2 in the energy productions, or make a deep renovation with insulation or installation of solar collectors, PV, what else. This study showed quite interesting results. So assumption was that 8% of current apartment buildings will be renovated. For instance, by making a deep renovation, when we see that CO2 savings are between 0.4 and 3.6% of the total CO2 production of a city. And the same ranges we see for the thermal, solar thermal. In some cases it's only 0%. And when we go to the heat pump installations, in some cases even CO2 can be increased. In some cases it can be reduced. So this shows how important is interconnection between the buildings and energy system. And it really depends what is the situation in the marginal electricity production. Would this then provide CO2 savings, or would this provide CO2 increase? And that's one challenge for the cities to tackle, because cities need to decide how energy is produced in the cities. At the same time, energy performance of the buildings is improved by the renovation all the time, and when to find these measures what could reduce CO2 most efficiently, that's the great question also for the further research. Coming to another example, in new buildings we know quite well that calculated energy performance should be what is called as nearly zero energy building. But very often measured energy performance can be even as high as double of that what was calculated in the design phase. And there are some take-care centers and school buildings as examples. So marked with green, we see one school building actually very close to Helsinki, Aurora School, where calculated energy use is quite the same what has been the measured energy use. So this is a good example, but in all other buildings in this slide, measured energy use is for some reason even by factor 2 higher than the calculated one, and that's indeed not the purpose. When this is a typical situation where cities need to manage hundreds of buildings and to have a good overview, when indeed good tools are needed to do this type of continuous performance monitoring, both for indoor climate and energy. And now we are going to a new pilot project in Finest Winds Digi-audit, with which aims to develop a new platform, new dashboards, and many new tools for this type of performance monitoring. And the starting point has been a need of large cities. So they have many take-care centers, many school buildings, and many other type of buildings. And this platform will provide an easy opportunity to connect all of these buildings and to follow, for instance, what has been energy performance in some segment of a school or take-care buildings. And these dashboards are developed at the different level, so executive dashboard will need much less information compared to departmental dashboard. And also one very important aspect is that performance monitoring is splitted from the maintenance. To do maintenance and fault diagnostics in automated fashion, that's much more heavy process, and that needs also other type of sensors, utilization, full utilization of a building automation system. So basically all sensors need to be connected to the systems and followed for this type of automated fault detection. This is possible and highly recommended, and then can lead to significant energy savings. But first screening, we recommend much more light performance monitoring, which will be based perhaps only 10 sensors and energy meters installed to the building. That solution would be very cheap one and would allow, for example, somebody in the city, some expert, to do this type of work and just to utilize the platform as a tool for performance monitoring. And when it is possible to see is there something wrong in some building or in some buildings with indoor climate or energy, and then if some improvements are needed, then indeed these automated fault detection tools and all these more heavy stuff would be needed. To show some example how indoor climate data can be shown as a traffic light colors. So if everything is green, there are example on the indoor air quality below, and thermal environment, both cooling season, both heating season. If all is green, then we are located in the indoor climate category 1 and 2, which represents either excellent category or just a good category. So indoor climate category 2 is a common starting point for the design for new buildings. And this is another example about the visualization of energy data. So if we have a single building view, we can see what are the main energy uses in one single building, and then on the right side we just see the portfolio view where we can see how many buildings belong to class A, for instance, or class B, class C, according to the energy performance certificate. So these are two examples, one of a system level example and another example on the building level, what both are highly relevant for the energy research in the smart cities. Thank you.